All right, problem 4 from the 2024 AP Calculus AB free response section. So here we got this graph, and it shows that it's going, we have the shaded region R, and it's going through these points, negative 6.5, y-intercept here at 2, and then also ends at 6, well, not ends, but it goes through 6, -1. And we're told that this is the graph of function f, and it has a horizontal tangent and -2. So the horizontal tangent there. It's linear on this part, so from 0 to 7. So it's one thing we want to make a note of. This is the linear graph. So on that interval, it would be -1/2 x plus 2. And then R is this region, and it has, I believe, an area of, yes, it gives you an area of 12 for R. Yeah, and it's bounded by this vertical line, x equals -6. So let's look at part A. Part A is we have the function g defined by this integral. We've got to find g of -6, g of 4, and g of 6. Okay, so let's work this through. I'm gonna do it on the different sheet of paper so I'm not cramming it all up in there. So you can see like the graph and the work. Okay, so we have, so g of -6 would then be the integral of f of t, or the integral just of this function from 0 to -6. Now, since the endpoints are backwards, we just take the area from -6 to 0 and multiply by -1. So the area from -6 to 0, that's what this area R is. So it's 12. But since, again, the endpoints are switched, this would be -12. That's the first one. Now g of 4, we would go from 0 to 4. So the integral of f from 0 to 4. Remember that the t is just a dummy variable. It's just, it just means that it's not necessarily going to be the same value as like 4 in this case, because we can't make, if we made it x as well, then it would always have to be like a 4. It would have to always match up. But it works the same way. So just in case you were wondering or confused about that. So we're just finding the area then from 0 to 4, which is just the area of this triangle here. So since we're told that this is a linear equation, we can just use the area formula for a triangle, which is 1/2 base times height. Base here is 4, the height is 2. And so then that will just have an area of 4 square units. All right, and then g of 6 will just be the integral from 0 to 6. Now we're already told it, or we already calculate that this is 4, but we're going to keep on going up to here. And then we have a smaller triangle here, and since it's below the x-axis, it's going to have an area of -1/2 2 times 1, so it'd be -1. This area would be -1, so we have 4 minus 1, and we'll get a total of 3. Okay, so that's part A. And then part B, what do we got here? Got, for the function g defined in part A, find all the values of x in the interval from 0 to 6 at which the graph of g has a critical point. Give a reason for your answer. Okay, so the critical points, we want to find where it has a potential maximum or minimum. To when we go about this, when we go about analyzing like an equation, we want to set the derivative equal to 0, or and look for undefined values of the derivative. So then we would want to find where, for part B, you're essentially Well, I can just do it right here. I don't have to. Part B, this would just be where g prime of x is equal to 0. Since g prime is equal to this integral, since g is equal to this integral, g prime would be equal to just f of t, or just we could write f of x now, I guess, because when you differentiate an integral, you basically cancel off the integral. So then we just want to find now essentially when is f of x equal to 0. And that just we just have to look at the point on the graph where it's 0, and that's going to be when x is 4. It'll just be this x-intercept there. So that'll be when x is 4. And then when it says give a reason for your answer, you would just say, I guess in like a sentence that you want to find where the function where the word g prime is undefined or has a 0. Okay, and then part C, function h is defined by the integral from -6 to x of f prime of t dt. Find the values of h of 6, h prime of 6, and h double prime of 6. Okay, so h of 6 would then just be the integral from -6 to 6 of f prime of t dt. Now, here's the trick, I guess. Well, not a trick, but here's what I think they were trying to assess. When you integrate, when you're integrating this, remember that you're trying to find the antiderivative. So since you already have the derivative, or f prime, then the antiderivative is just f. So we're just going to evaluate f of t from the endpoints -6 to 6. So we're just going to have f of 6 minus f of -6. And we would get f of 6 would be right here, -1. And f of -6 is 0.5. So then our answer would be -1.5 for that first one. Whoa. And then h prime of 6, we find, so this is even easier because now we take the derivative of this integral and that just cancels out this integral. So then we just have that f prime of 6. So we just look for the derivative at 6, which is basically just the slope of this straight line, which we have as y equals -1/2 x plus 2. So then it'll be -1/2. And then the last one, h double prime of 6. That's going to be f double prime of 6. Same thing. Well, not same thing, but we're still working off of that. And then we're just looking for then a second derivative of f at the point 6. Now, since this is a straight line, you're taking the derivative of this equation twice. So the derivative here would be 1/2 or -1/2. But then the derivative then, so then y prime would be -1/2, right? And then y double prime would just be 0. Because the derivative isn't changing values. Remember, the second derivative describes how the first derivative is changing, and this first derivative is not changing because it's just saying a constant value of -1/2. So then the second derivative is just 0. The calculations weren't too bad. I think they're just looking to see if you understand the concepts. Okay, so I hope that helps. Let me know if you have any questions or any comments, or if I explained something weird. I'm always looking to improve. So just let me know. Feedback is always welcome. And I'll see you guys in the next video. I'm going to work now on the 5th free response problem. So see you guys then.